Okay, so I just want to summarize what we've been talking about in 4.3 prior to Thanksgiving and 4.4 now, starting yesterday. And the two things that we've talked about are the first derivative test and the second derivative test. And I haven't called them that, but I'm going to call them that now. So the first derivative test uses f prime, the first derivative, to give us information about f, okay? And so some information that f prime of x can give us is that if f prime of x is positive or greater than 0, then that means that f of x is increasing. We'll see if I can squeeze that on the screen. Yep. And I also know that if f prime of x, that first derivative of f, is negative or less than 0, this means that f of x is decreasing. And that is not new news, okay? That is old news. You used that news to help you answer questions on your quiz, right? So if I have that f of x is increasing, then the slope would be positive. If I have that f of x is decreasing, then the slope would be negative, okay? Not new news. Okay. I also know that if f prime of x changes from positive to negative, this means that f of x has a maximum value. And again, I also know that if f prime of x changes from negative to positive, this means that f of x has a relative minimum. Again, not new news. This is old news, okay? So here's my graph of f. And notice that my slopes to start this curve are changing from positive slopes of the tangent lines to negative slopes. F has a max. My slopes change from negative slopes to positive slopes for the tangent lines, and so I have a min. Okay, and so that's what the first derivative test gives me, and in order to make these determinations, I find f prime of x and I set it equal to 0, or I determine when f prime of x does not exist, and these give the critical values for f. And that is what helps you make your sign chart for f prime, this little nugget of information right here. And once I make that sign chart for f prime, I can answer all of those arrows above, okay? Okay, now we have talked about something called the second derivative test. And believe it or not, the second derivative test relates to the second derivative of f, right? Mathematicians are not creative in the names that they give. They give you names for exactly what things mean, okay? And so my second derivative test gives me information using f double prime. Okay, so if I find f double prime of x to be positive or greater than 0, this can mean a couple of things, okay? So this means that f of x is concave up. And this also means that f prime of x is increasing. So I can keep track of two connections now for f double prime. F double prime is connected to f. That tells me the concavity of f. And f double prime is connected to f prime. Just like, take a look. This is fantastic. I love this. Just like when f prime of x is positive, f is increasing. When f double prime of x is positive, f prime is increasing. Okay, so similar connection. We're just a layer up in our derivative. Okay. Okay. Next, if I know that f double prime of x is negative, again, this means two things. It tells me something about f. It means that f is concave down. And it tells me about f prime. It says that f prime is decreasing. And again, that is a very similar relationship to what we stated up above. Up above, we stated, I'll make sure I can capture it all. Up above, we stated that if f prime of x is negative, that f of x is decreasing. Similarly, I can state that if f double prime of x is negative, then f prime is decreasing, okay? So same relationship. I just have two derivatives to deal with, okay? And the last bit of information that the second derivative can give me is that if f double prime of x equals 0 and changes signs, and that's really the key, and changes signs. And so I'm just going to highlight if f double prime of x is 0 and changes signs, okay? Then f of x has a point of inflection at the x value where that second derivative is equal to 0. Okay, so now we have all the connections. These are justifications for any question that were asked from here on out about f prime, f double prime, and what's happening with f in terms of f increasing, decreasing, the extreme values of f. Is f concave down? Is f concave up? And what are the points of inflection for f? This is your gold, and you're going to use these statements as your justifications.